The question says, this is Newton's laws, forces, and so on, tensions, frictions, inclinations, mass acceleration. Okay, question 1. 2 blocks of masses 20 kilogram and 5 kilogram. Here's a 20, here's a 5 kilogram. Respectively are connected by a light inextensible string, a string that does not stretch. P, this string here, it's called P. There's another string here which is called Q. A second light inextensible string, Q, attached to the mass of 5 kg block, this one here, runs over a light frictionless pulley. Here's a pulley there. That will. A constant horizontal force of 250, this one here, 250 newtons, pulls the second string as shown in the diagram below. The magnitudes of the tensions in P and Q are tension 1 and tension 2 respectively. Ignore the effect of air friction. All right, 1.1.1, state Newton's second law of motion in words. This you can get it from the textbook. Newton takes the acceleration of an object. Then he says it is directly proportional to the net force and inversely proportional to its mass. And the direction of the acceleration, it's in the direction of the net force. Those words I just said, that's what they wanted. They wanted it in words. This is in a formula way. I said what that formula says in words. All right, now next. If you are going to calculate this thing, here's a clue. A clue, you will always do the net force. Net force equals to MA. You have to do the net force of each object. There are 2 objects. You'll do F net for the first block and F net for the second one. I'm talking in general, these laws of Newton's. The second thing that we normally apply is what I call the fun. Friction equals to mu, coefficients of kinetic friction or static friction, times by F subscript N, meaning the normal force. Some of you just put a capital letter N. It doesn't matter whether you put N or F subscript N. It's the same thing. Every time you are working with these 2 formulas, every time without fail, then you know the whole chapter, you have mastered it. So I already know in advance, I must go to the first block and do all of this. Go to the second one, do the same thing, F net. Go to the first, apply fine. Go to the next, apply fine. And then I'll be able to answer every question that comes. All right. Now, how do we calculate that? It's simple. First, when I look at the first block, which is the 20 kilogram, I want to identify all the forces acting on the 20. Then I'll say there is a force of gravity pointing downwards, which is called the weight. It will be given by 20 and then multiplied by 9,8. We're going to work it out. There is a tension pointing upward, which is that T1. These are the 2 forces acting on that object. So if they ask me to draw a free body diagram of the 20 kilogram, I will represent it as a dot. Show a force that is pointing downwards, which is the weight or the force of gravity. And I'm going to show the force also pointing upwards, which is that tension 1. This is a free body diagram. We normally use a dot. All right, I've shown the magnitude of the weight, which is also here. Next thing, I move into the next block and do likewise. On this block here, there is a force pulling downwards. The force that's pulling downwards, which is the force of gravity for that block, which is going to be given by 5 multiplied by 9,8. We'll do the calculation. But that's not the only one. There's a tension, that red tension. It's still acting on that block. It's also there. Okay, I'm showing it as a tiny little bit one there because I don't have space for this one. Unless otherwise, I kind of shift this one a little bit down. Then I'll be able to show you the other one, which is that one here. It's also the tension, the red one. Not only that, but there is an upward force also, which is tension 2. If they ask me to draw a free body diagram of the 5 kilogram block, I use a dot. Then I must show them there is a tension force pointing that downwards. There is another force pointing down, which is the force of gravity. So I don't know the length of this line, which one is stronger, which one is weak. I haven't done that. And then upwards, there is tension 2. This is a free body diagram of this one. All right, so at this point, we can work out 5 times 9,8. I think it's 49. Yes, it's 49. But remember, the tension is on string 2. That string 2 goes over like that, which means that tension is 250 newtons. So T2, we already know it's 250 newtons. So step number 1, to apply Fnet and the fan, you must show all the forces acting on the object. This is the strategy, regardless what the question are coming. All right, then the next thing that we need to understand, they will definitely ask you to calculate the tension, a force, normally tension, and the acceleration. Since this thing is being pulled upwards, so it means the motion, it's upward. That is the movement, the acceleration, meaning the bigger forces are the ones which are pulling upwards. Those are the winning forces. Then let's apply for this one here, net force, this one. So it will be upward force minus bottom. So for object 1, it's going to be T subscript 1 minus that 196 top minus bottom equals to MA, because this represents F net, meaning all the forces acting on an object. But then the good news is we know what is the mass of this object, which is 20. So we'll go ahead and substitute it. So we'll write that as 20 multiplied by A. So since I already know in advance there are 2 objects, we're gonna have one equation and second equation. Number 2. For this one, the block 5 kg will say upward force, which is the 250 minus tension 1 minus the 49. So it's gonna be 250 and then minus tension 1 and then minus the 49, because all of that represent F net, all the forces acting on an object, equals to MA, M, we already know the mass, it's 5, and then times by the A. So at this point, we have applied F net for both blocks. To apply FUN, mu n, or the fan, there must be a surface. These things are flying in the air. They are not moving on a surface or on a wood or a table or on the ground. So there will be no friction. So this one will never apply. So then once you have these 2 equations, you are going to do your simultaneous to solve for A or tension. So we can call that equation number 1. And the second one we're going to call that one equation number 2. This is how it works all the time. So I can say from number 1, let's work from number 1. I'm going to write from number 1. I'm doing that to bring your attention. I'm going to solve for T1. 196, that negative goes to the right-hand side. So I'm going to have T subscript 1 equals to 196. And then plus the 20A. The mathematician will be calling this one equation number 3, which is nothing else but equation 1. So therefore, all of this needs to go here, but I must put them in a bracket because there's a minus that will change the sign of 196. That will change the sign of 20A, or I might as well change the sign one time. All right, so now after you substitute, you're going to have 250. I'm doing it after changing the sign. It's going to be minus 196. You understand that because you're in grade 12. Minus the 20A, and then minus the 49 equals to the 5A. Then I'm going to group the A. This to a negative 20, I bring it over to the other side. Then that are numbers. I'm just going to add them together. I'm doing it right now. When you add the numbers, you end up with 5. When you transpose the negative 20 to be added to the 5, it will be 25A. You're going to divide everything by 25. Then you have the value of A. Your acceleration is going to be 1/5. If you don't want to keep it like that, you can change it and write it as 0.2. It will be meters per second squared. Since up to this point I haven't given the direction, this will be the magnitude. But then I can now say upward. Okay, let me just, anyway, it's fine. Let's call it upwards. It's moving upwards. So that is the acceleration. But then, according to the mathematician, we can come back here, substitute for A, and get tension. So I'm going to do likewise. This is like a normal simultaneous. So T subscript 1 is going to be 196, and then plus 2 into 0.2 because that is an acceleration. And then I'm going to punch my calculator to get the answer. We get 196.4. That will be newtons. All right. So now let's read the questions. The questions say draw a label-free body diagram indicating all the forces acting on the 5 kg block. The idea is to do for all the blocks. Don't wait for them to tell you do for 5. Because the next question that says calculate the magnitude of the tension in P. You can't do it without doing the free body diagram of the other object. So the idea all the time, get all the free body diagram of each block. Apply F net. Apply the fun. You do the calculation. You find yourself having answered everything that could possibly or almost ask. And then we did, which is this one. We gave them a Banzella and gave them this one for the 20 kg. Now they say calculate the tension of the magnitude of the tension T1. We did. Yeah, we got the tension. We had to do the simultaneous equation. And then number 1.5, they say when the 250 Newton force is replaced by a sharp pull of the string, one of the two strings break. Okay? They say which one of the two strings, P or Q, will break. So the idea here is, okay, if we take this string here, this one here, and really pull this string, this one, very sharp, like powerfully, which one will break? So the question is, between the string 2 and string T1, which one experiences greater force? At this point, we can see string 2 experiences the 250 force. But the tension here, it was 196.4. We good, ne? So the tension in this one here, it was 196.4 Newton. We okay?
Yes.
But at this is the force that's pulling downwards or trying to pull this string apart. But there is again a 49 Newton. You good, ne? Or you could say on this string here, T, there is a tension that's pulling downwards of 196. And this string at the same time is being pulled by, it's attached to this, the 196 Newton. Am I right?
Yes.
Yeah. So this is the one that will be like most likely to cut off, or the one that has a greater force between it. So I'm just giving you in that sense so that you can know as a general answer, the one that will experience greater force. It's 250. You just calculate the forces here. Just look at the one that are pointing down. Is this, and this one, and also this one, which are greater. All right, so it's that string. Thank you.